Welcome back to Inside Factory Produce. Today, we are stepping into a realm where the boundaries of industrial scale are completely redefined. Imagine a structure so long that it rivals the height of a 40-story skyscraper. Yet so delicate that its aerodynamic shape is measured in mere millimeters. We are inside a specialized factory that spans over 500 meters, a hangar of titanic proportions designed for one singular, noble purpose: to craft the wings of the wind. Look at these shimmering white curves stretching endlessly into the distance. This is not just manufacturing, this is industrial art on a colossal scale. A single worker standing at the root of this blade appears like a tiny dot, a mere whisper against the thunderous silence of these fiberglass giants. These blades, some stretching over 100 meters in length, are the absolute heart of the global renewable energy revolution. They are engineered to capture the invisible power of the wind and transform it into the electricity that fuels our modern lives, our cities, and our dreams. But how do you build something this large that is also light enough to be spun by a gentle sea breeze? How do you ensure that a 100-meter arm doesn't snap like a twig under the weight of a violent hurricane? The answer lies in a perfect, high-stakes marriage of advanced composite science and meticulous, patient human craftsmanship. On these massive industrial touchscreens, every stress point is heat mapped, every individual fiber is accounted for. Before a single drop of liquid resin is poured, the blade exists as a perfect digital twin in a virtual world. Today, we witness the birth of a sky giant, a story of how human beings use their relatively tiny hands to build the massive tools that will save our planet's climate. Let us begin this epic journey of engineering without limits. The journey of a wind blade begins not with a machine, but with the humble human hand. The mold, a 100-meter-long cradle of polished steel and composite material, must be prepared with absolute perfection. Any tiny speck of dust or microscopic imperfection here would be magnified on the final product, potentially causing a structural failure at sea. Workers polish the surface until it reflects the factory lights like a mirror. Then apply a pristine white gel coat. This is the skin of the blade, designed to protect the internal structure from harsh UV rays, corrosive salt spray, and the abrasive force of the wind for 25 years. Once the skin is set, the true labor-intensive phase begins. This is the dry fiber mapping phase, where thousands of square meters of pure white fiberglass fabric are laid down by hand. Watch the incredible synchronization of the team. 10, 20, or even 30 workers move in perfect unison to lift and position these massive, heavy sheets of fabric. It looks like they are drapes for a giant's palace. But this is a high-stakes puzzle. Every layer must be smoothed out, every tiny ripple must be banished. A single air pocket or a slight misalignment could lead to a catastrophic structural failure years from now. 100 meters in the air. The contrast is staggering. See the workers kneeling inside the 4-meter-high mold cavity, appearing like ants inside a white canyon of fabric, to provide thickness and rigidity without adding excessive weight. Lightweight balsa wood and foam core blocks are carefully integrated into the layers. This is a hybrid of nature and technology. Then, we see the spine, the shear web, being lowered into place. It is the skeletal structure that will keep the blade rigid against the relentless pressure of the ocean gales. The human element here is irreplaceable. Machines simply cannot match the tactile intuition required to weave these complex layers into a unified whole. Now, we reach the most critical and nerve-wracking phase of the entire process: vacuum resin infusion. This is the chemical alchemy where thousands of layers of dry fabric are transformed into a single, rock-hard composite structure. The entire mold is sealed under a clear vacuum bag, and the air is sucked out until the film grips the fabric with crushing atmospheric force. Then, the valves open. Watch as the golden amber resin begins to pulse through a network of transparent tubes. It moves like a rising tide, bleeding into the white fibers and turning them into a translucent gray. This is a high-stakes game of time and chemistry. The resin must reach every single corner of the 100-meter structure before it begins to harden and cure. The engineers watch the pressure gauges with bated intensity, their eyes never leaving the monitors. They are looking for dry spots, or resin-rich areas that could compromise the delicate balance of the blade. As the resin front moves toward the narrow, razor-sharp tip. The tension in the factory is palpable. Once the infusion is complete, the curing process begins. Infrared heaters glow red above the mold, triggering an exothermic reaction that generates intense internal heat. The liquid resin becomes a solid matrix, locking the fibers into a permanent, indestructible shape. After the cure, the two halves of the blade, each 100-meter shell, are ready to be bonded together. This is a breathtaking sight. Two massive cranes lifting the halves into a vertical position, applying a thick bead of structural adhesive, and closing them together like a giant's mouth. A specialized worker must then crawl into the dark, hollow interior of the blade to inspect the bonding from the inside. It is a lonely, claustrophobic journey through a 100-meter tunnel of darkness, guided only by a small flashlight. This inner sanctum is where the true strength of the Titan is verified and sealed. Once the blade emerges from the mold as a single, unified structure, the work is far from over. It is now a raw Titan that needs to be refined and polished to perfection. Workers in full white protective suits descend upon the blade with pneumatic sanders. They are smoothing out the bonding lines, creating a seamless, aerodynamic profile that will allow the blade to slice through the air with minimal resistance. The air in this section is filled with a fine white dust, making the factory look like a silent winter landscape. After sanding, the blade is moved to the automated spray booth for its final coat of UV-resistant, weatherproof paint. The finish must be as smooth as polished silk to ensure that air flows over the surface with zero turbulence. Efficiency in the sky depends on the perfection of the surface here on the ground. But beauty is nothing without strength. Every single blade must undergo rigorous, violent testing to ensure it can survive the ocean's wrath. We see the static load test, where a massive mechanical rig pulls the tip of the blade, bending it several meters toward the ceiling. It is terrifying to watch a 100-meter structure flex like a giant bow. But this is proof of its incredible elasticity and strength. High-tech X-ray sensors then slide along the length, searching for any hidden internal voids or bubbles that the human eye might have missed during the infusion. We even see the lightning protection system being installed, a copper tip that will channel millions of volts of electricity safely down through the tower and into the ground. Finally, the blade is balanced on a precision pivot, for a 100-meter arm to spin at high speeds. Its center of gravity must be accurate to within a few grams. It is a monumental task of precision for a monumental object. Every centimeter of this blade is a testament to human engineering prowess and our desperate desire to harness the elements. The journey of the blade ends where the wind begins. We watch as these white giants are loaded onto specialized, multi-axle transporters for their long trip to the coast. The blade tip swings high over the trees and local buildings as the truck navigates tight curves. A surreal sight of industrial power moving through the quiet, rural countryside. At the deep water port, they are hoisted onto massive cargo ships, looking like a forest of white pillars crossing the open sea. Finally, we see them at their destination, a massive offshore wind farm, 150 meters above the crashing waves. Workers suspended on ropes and harnesses bolt the blade into the turbine hull. It is a moment of pure triumph for everyone involved. The turbine begins its very first rotation. The blades slice through the air with a rhythmic, powerful whoosh, a sound that represents the clean, sustainable future of our planet. These three blades, spinning in a perfect, hypnotic circle against the deep blue sky, are now generating enough clean electricity to power thousands of homes and industries. From the tiny hands that laid the first layer of fiber in a quiet factory to the massive machine that now stands defiant against the ocean storm. The story of the wind blade is a story of human potential and our ability to solve the greatest challenges of our age. Inside Factory Produce is proud to bring you this behind-the-scenes look at the giants of the sky. Every single rotation is a heartbeat for a cleaner, greener world. We are proving that we can live in harmony with our planet if we use our technology wisely. Don't forget to like and subscribe to stay updated on the world's most incredible and secret manufacturing stories. Until next time, remember, the wind is free, but it takes the full strength of our imagination and our engineering to catch it. The future is bright, the future is green, and the future is built by the hands of those who refuse to accept limits. The giants of the sky are ready to fly.
Inside Factory Produce. Powering the future.